your desk of everything but your Chromebook. And I'd like you to open up to lab number 11, which was assigned to you this morning. That is due tomorrow. We're going to get started with that. And I am going to have you partner up with the person sitting next to you. So that way you can collect data a little more efficiently. So let me give you all a minute to get your Chromebooks out and open. Open it up to lab 11, which is due tomorrow before class begins. And once you have it open, it's going to look like this. So what I'm going to do is just get it started by showing you how this lab works. In this lab, we're going to be doing some conceptual investigation about factors that affect the motion of a projectile fired at an angle. And we're going to use a PhET simulation. It's the same simulation we used in lab 10, the horizontally fired projectile lab. So I've got that simulation open here. And what we're going to do is open up the simulation and click on the intro tab. So I'm going to click on that intro tab, and here we are. In this lab, we have to do some changes to how things are set up. So I'll show you how to do that real quick. First thing we want to do is adjust the height of the cannon to 0 meters. So you're going to click and drag the cannon down to the ground. So it is right on the ground at a height of 0 meters. I'll make this bigger so you can see that's 0 meters. Then the next thing we need to do is adjust the angle so it's set to 45 degrees. The way we do that, click on the barrel of the cannon and move it up to 45. There we are. Next thing we want to do is now go to part 1, where you're going to test the effect of the initial speed. Let me just show you how to collect the data. We'll do one row together in each part of the lab, and then I'll ask you to break up each part. So you do half, your partner does the other half, and then you share the data. So that way it's not quite as repetitive. So the first thing we're going to do in part 1, where we're testing the effect of initial speed on the parabola, is we are going to set the initial speed of the cannon to 3 meters per second. So in this simulation, I want you to drag this down to 3 meters per second. I'll do the first one for you. Just follow along how I'm doing it. And then we fire it. Now we get a really, really tiny parabola, and that's okay. We're not going to adjust what we're firing today. Just leave it at the pumpkin. It makes things a little more complicated if you keep making those adjustments. Then we're going to bring the blue measuring tool over. And this is trickier than in the last lab because you need to measure at 2 different points in the parabola. First thing we want to do is get the hang time. Now, this is at the end when it's at the ground. You want to go to the end point where it lights up yellow, and we see that the height is now registering 0 meters. If it's not registering a height of 0 meters, you're not in the right spot because there are actually 2 dots super close to each other at the end of the parabola. There's the hang time, and there's the range. So now I'm going to go into the Google Sheet, and I'm going to type those values in. 0.43, and what was the range? 0.92 meters. Now, to get the maximum height, I have to go to a different point in the parabola. Do you see that parabola? I wish I could make this bigger. I can't make it any bigger than it already is. You see how there is a fluorescent green dot right in the middle of the parabola? That's where you want to put your blue measuring tool. Have that green dot light up. You see it lights up green? And now that's where you get your maximum height from, which is 0.23 meters in this case. We're all going to get the same numbers for each trial. That's why you can easily do this with a partner and share it. So you do like the first half 3 to 9 meters per second. They do 11 to 17 or whatever, something like that. Let's look at part 2. Part 2, we're going to test the effect of changing the launch angle. So what I'd like you to do in this simulation is reset the whole thing. Please bring the cannon down to the ground. Again, keep the speed at 15 meters per second. And you'll see that we want to start at an angle of 30 degrees. So you're going to drag this up to 30 degrees and you're going to fire it. That went out further. Now what I'm going to do is use my blue measuring tool to measure the range, the hang time, and the maximum height. So again, I need to go to the end. Lights up yellow. I see the height is 0 meters. I'm going to record that time and that range for the 30-degree angle. So that hang time we found to be, 1.53 seconds. And the range was 19.86 meters. Now, to get the maximum height again, I need to go to the middle of the parabola where that fluorescent green dot is, and that needs to light up green. And I see my height for this angle was 2.87 meters. Yes. Yep, that is correct. Okay. So again, you're going to split up this table. So you do half, your partner does the other half. Okay. And then you share your numbers. Let's look at what we do in part 3. I'm actually going to do the first 2 rows with you. Part 3, we want to see what air resistance does to launching the projectile. So follow along with me. We'll do this together because there's some other options we need to change. The first thing we need to notice, I'm going to reset this. I'm going to bring the cannon back down to the ground. And I notice that I want to start with a speed of 15 meters per second at an angle of 35 degrees. So let me make that 35 degrees. There's my initial speed, 15 meters per second. I'm going to fire it. Do you notice how the parabola is blue? Dark blue. That's important. That means there's no air resistance. And like we did previously, we're going to measure those 3 variables, the hang time, the range, and the maximum height. So here the hang time is 1.75 seconds. The range is 21.55 meters. And now to get the maximum height, we're going to go to that fluorescent green dot in the middle of the parabola. There it lights up green, and I see the height is 3.77 meters. Now to do the next row, the only difference is that it now says we want to do this with air resistance. So the way we make that happen in the simulation is we click this button over here, which says air resistance in the top right. Click that button, which says air resistance. You don't have to clear the screen. Just go ahead and fire it. You can see a big difference. Now the trajectory is pink with air resistance. We're now going to go ahead, bring that down here. I'm firing the pumpkin. I see my hang time is 1.7 seconds. So we're going to type that in. Same angle, same speed, just it doesn't go, it's not in the air as long. Next thing I notice is that the range is 19.2 meters. So let's go ahead and type that in. And then to get the maximum height, we go to the middle of that pink parabola at the fluorescent green, and we record the height, which I got 3.54 meters. Whoops. So I would recommend in part 3 that one of you does the 65-degree angle, the other does 90. Split it up that way. Okay? Just get the data collected, and once you're done collecting the data, close out the PhET simulation. And then we're going to work on making the graphs together and answering the questions. Okay? Go ahead, get to work on that. Start collecting your data, share. I'll freeze things out until you get all your data in there. Jace, what's up? Oh, you're doing a cannonball, that's fine. So your numbers are going to be different. Are you on the intro tab? Doesn't looks a little different. Yeah, that's where you should be using this one the whole time. I don't care what you fire, but usually the pumpkin's the easiest one.
Zero meters, 45 degrees. So this I
How are we doing with the data? Getting there? Okay. Who's still collecting? Okay, looks like we're almost done though. Good. See, a lot of you are still working. I can't tell if you're moving ahead without me or if you're still working on data. How many of you are still working on getting data? Okay. Good. Kira, feel free to look on with Alex or Julia too, if you need to get data. Everybody good? No, not yet. I'm gonna tell you now, the graphs in this are a pain in the butt. Sorry. Okay, we're ready to get started? I'm gonna walk you through it. So let's go to make sure you're in part 1 with me. We're gonna make the graph for step 2. And this wants a scatter graph of hang time versus initial speed. This is probably the easiest one of them all. So go ahead, click where it says initial speed in meters per second. Shift key down, keep it down, right arrow over to hang time, then down arrow to select those numbers, please. Okay, we're going to insert a chart. The chart type is incorrect. We want this to be a scatter type. Now, you should see that the x-axis says initial speed and series says hang time. Yes? Okay, go to customize. Chart and axis titles. We expand the submenu, start with the chart title. This is a measurement of the hang time versus the initial speed. I know that sounds backwards. Normally we do speed versus time, but this is hang time versus speed because we were changing the speed in the experiment. We need the speed on the x-axis. So now go to the horizontal axis title. This should be initial speed in meters per second. Horizontal is initial speed in meters per second. The vertical axis title should be hang time in seconds. Now here's the next problem. This graph does not have a y-axis on it yet. Do you see there's no dark bold line vertically? To get that there, we have to set the minimum value on the horizontal axis to 0. So go ahead and set the minimum value on the horizontal axis to 0. And now I can see both the bold X and Y axes that I need. Okay, so now what we're going to do, collapse that menu, and let's go to series. We're going to add the trend line for this. Select trend line. Linear looks really good to me. And now we have to add the equation. So for the that graph is now complete, but we need to click it and drag it down and move it into the space below item 2. I'm going to close the chart editor. I think my graph, yeah, it's a little too big, so I'm going to shrink it so it fits and doesn't cover up the directions for step 3. Okay, can we go on to the next graph? All right, step 3 wants a graph of range versus initial speed. The easiest way to do this is to start with initial speed, hold down your shift key, right arrow over all the way to range. You're going to select multiple columns. Then down arrow to get the numbers. Insert chart. Change the chart type from column chart to scatter. Now, this is where we're going to make some modifications. Keep on the x-axis the initial speed in meters per second. But on the series, we don't want the hang time. So remove that. All we want is the range. That's easier than trying to select one column which is far apart from another. Now go to customize, chart and axis titles. Let's get the chart title on there first. This is a graph of the range versus the initial speed. The horizontal axis title is initial speed in meters per second. The vertical axis title will be range in meters. Let's now get the minimum value on the horizontal axis, set it to 0 so I can see both the X and Y axes. And now we're going to add our trend line, which is under series. Linear is not a good fit at all. So the next option you should try is power series. If power series fits, you're good. It fits it beautifully. So for label, say use equation. We're now going to click and drag this graph down into the space for item 3 on the page. Why don't we take a break, and when we come back, we'll work on finishing the graphs, and then we're going to go to the next lab. So all you have to do are the questions in the lab, which are pretty easy. So go ahead, take a break if you need to. That's good. Mhm. In the top bin. Yep, please. Thank you. All right, ladies and gentlemen, I'm going to show you how to finish this last graph for part 1. So what we're going to do in this last graph is we want to graph the max height versus the initial speed. So let's head up here. We're going to select all of the data in the table this time. I know it sounds excessive, but it's actually easier than trying to select 2 columns, which are so far apart. Go to Insert Chart, change the chart type to Scatter. On the x-axis, we want the initial speed, but we do not want the hang time on series, so remove it. We also don't want the range. We just want the maximum height. Now we're going to go to customize this with our titles. Let's start with the chart title. This should be a graph of maximum height versus initial speed. Can you see that okay up on the screen? Or is it too small? It's okay? All right. Now we're going to go to the horizontal axis title. That stays initial speed in meters per second. The vertical axis title is going to be maximum height in meters. Now you'll notice that again, I don't have a y-axis on the graph. So to do that, we set the minimum value on the horizontal axis to 0. Now we're going to add our trend line under the series option. Linear is a lousy fit. So what should we try first? Power series. See if that fits. That fits it beautifully. So that's the one we want. And for label, say use equation. Now that graph is all complete, we can click and drag it down into the space for item 4 in part 1 of this lab. And now we can go on to the graphs in part 2. Can we go to that? I'm not hearing anyone say no, so I'm going to go on. Part 2. Step 2, we want to make a graph of hang time versus launch angle. This is the easiest one to do because the 2 columns are adjacent to each other. So select launch angle degrees, hang time in seconds, and the data below. I want to remind you, all of this is being recorded. So if you miss something, you can always go back to the recording later to get it and fix it before you turn this in tonight. Go to Insert Chart. Change the chart type to Scatter. X-axis should say launch angle in degrees. Series should say hang time in seconds. Let's customize this with our chart and axis titles. The chart title is hang time versus launch angle. Hang time versus launch angle. The horizontal axis title is the launch angle in degrees. The vertical axis title is hang time in seconds. Now notice again, I don't see a y-axis on there. So to do that, we go to the horizontal axis menu and set the minimum value to 0. There we go. Now we're going to add our trend line under series. Linear does not fit well. So what should we try first? Power series. Power series is not, it's an improvement, but it's not great. So the next option to try after power series, when we can see this is not linear, try polynomial. And that one fits it perfectly. Polynomial. For the label, say use equation. Now you're going to click on the graph, drag it down into the space for step 2, and resize it so that way it doesn't cover up step 3 if necessary. All right, step 3. Now we want to do range versus the launch angle. So similar to what we did in the last section, you're going to select the 3 columns, launch angle, hang time, and range with the data. Insert chart. Change the chart type to scatter. The x-axis should say launch angle in degrees. Get rid of the hang time. We don't want it. We just want the range in meters. Now we're going to customize it. Chart and axis titles. The chart title is the range versus the launch angle. The horizontal axis should be the launch angle in degrees. The vertical axis title should be the range in meters. Now again, I don't see a y-axis, so I'm going to add that in under the horizontal axis, set the minimum value to 0. Now we add our trend line. The trend line obviously is not linear. So let's try power series. Nah, that's no good either. So what's next? Polynomial. And that fits it beautifully. As good as we're going to get. So now for the label, say use equation. That graph is now done. We can move it into the space for step 3. Last one to make for the lab. There's only one more graph here. We're now going to make a graph of height versus launch angle. So we're going to select all the data, insert the chart, change the chart type to scatter. We want the launch angle on the x-axis, but we do not want the hang time. We do not want the range. We just want the height. You're starting to see a pattern on how these are done. They're all done the same way. Customize this, the chart and axis titles. The chart title is the maximum height versus the launch angle. The horizontal axis is the launch angle in degrees. The vertical axis is the maximum height in meters. I don't see a y-axis, so I have to set the minimum value on the horizontal axis to 0. Now I can add my trend line under series, not linear. So let's try power. No, that's not better. Let's try polynomial, and that fits it pretty well. Now that we have polynomial as our choice, we're going to say for the label, use the equation. We can now take the graph and move that into the space for step 4 in part 2. Okay? The only thing left in the lab, part 3, there we got our numbers. We're going to go to the analysis. You'll see that in the analysis, the questions are broken up for part 1, for part 2, and for part 3. I'm telling you where to look for the answers. Okay? I'm going to help you out. Let's do part 1 together. Part 1 says, when the initial speed of the projectile increases, which measurements also increase? And the measurements you can pick from are hang time, range, and max height. So let's go to part 1. We're going to look at the graphs. All the graphs have initial speed on the x-axis. When this speed went up, did the time go up? Hello? When the speed went up, did the time go up? Look at the graph. Yes? Okay, remember that. Look at the next graph. When the speed increased, what happened to the range? It increased. Remember that. When the speed went up, what happened to the height? It also increased. So now we can answer the question in a complete sentence. When the initial speed increases, the hang time, range, and maximum height increase. Number 2, what's the shape of the trajectory of a projectile? Do you remember when you were watching the simulation? What shape did we get for the trajectory? Yep. So the shape of the trajectory is a parabola. And I think you know the answer to this as well. If the projectile lands on the ground in a certain amount of time, about when will the projectile get to its maximum height? When does it get to the peak? Half the time. That's right. So the projectile reaches the maximum height in half the time. You want to just go on and finish it? All right, part 2. Now we're going to look at the graphs in part 2. What angle gave us the biggest range? So let's go to that graph with the range and the launch angle. There it is. What angle is producing the peak on that graph? The peak is right about here, yes? What angle is that? Yeah, it's 45 degrees. All right, so let's answer that here. A 45-degree launch angle produces the largest range. What angle gives us the biggest maximum height? So let's look at the graph with maximum height and angle. What angle is giving us the peak of this curve? What angle would that be? Hello? What is it? 90 degrees. All right. So a 90-degree launch angle produces the largest maximum height. What angle gives us the biggest hang time? All right, so let's go to the graph with the hang time, which is the first one. What angle gives us the highest or biggest hang time over here? So come over and read down. What angle is that? Even without doing the lab, you should know the answer to that. Which one gives you the biggest hang time? 90 degrees. All right, next one. Number 7, compare the ranges for pairs of angles, 30 and 60 and 40 and 50. So let's go to the table for this. Look at the range for 30 degrees. You see it? Look at the range for 60 degrees. What do you notice about those two ranges? Same. Okay, look at, they said 40 and 50. What do you notice about those ranges? Also the same. Okay, so now let's answer the question. What pattern do we observe for those angles and their ranges? Well, the ranges for each pair are the same. Now, what is the sum of those paired angles? So if you add 30 to 60 degrees, what is their sum? 90. What about if you add 40 to 50? Also 90. So the sum to 90, you will get identical ranges, as the simulation just pointed out to you. All right, last part, number 3. 3 questions. First question, what is the overall effect of air resistance on hang time? So let's look. There's no graph for this. Let's compare without air resistance to air resistance. What do you notice about the hang time with air resistance compared to the one without? Shorter. What about, are they all shorter with air resistance? Okay, so let's answer that. Air resistance decreases the hang time. What's the overall effect of air resistance on the range? All right, so let's look at the ranges. What do you notice about the range with air resistance compared to that without? Famer? It's less, that's right. So air resistance decreases the range. What's the overall effect of air resistance on the height? So look at your data. Look at the height with air resistance compared to that without. What do you notice? Giovanna, can you tell me, what do you notice? So with air resistance is bigger than without? It's lower, that's right. Good. So air resistance decreases the maximum height. And that's it. Make sure you get out of the cell. You can turn it in Google Classroom. And that is it for the lab. If you didn't finish it, please make sure you finish it tonight.